Before the first brick was ever fired, before the first nail was ever hammered, before the first blueprint was ever drawn, human beings were already solving one of the most urgent problems life had ever given them. Not war, not hunger, not even disease. The problem was simpler, and yet more terrifying than all of those things combined. The problem was this: the world around them wanted to kill them. Wind that came in the night with the fury of a living thing. Rain that could dissolve the ground beneath their feet. Heat that baked the earth into something harder than bone. Cold that reached through any crack in any wall and turned sleeping bodies into stone. And the earth itself, the very ground they stood on, that would occasionally shudder and groan and split open without warning, swallowing everything built upon it. And yet they built anyway, not just shelters, not just walls and roofs thrown together in desperation. They built homes. Homes that have outlasted their builders by thousands of years. Homes that still stand today, on cliffs and in deserts, and on mountain slopes, defying every storm that has come since, defying the slow collapse that takes everything else, defying even time itself, that most merciless force of all. The question that has haunted architects, historians, archaeologists, and curious minds for centuries is not simply how they built these homes. The deeper, more fascinating question is why. Why did they build them this way? What did they know that we have forgotten? What forces were they responding to that we have only recently begun to understand again? And what does it mean that some of the most structurally brilliant buildings in human history were built not by trained engineers with computers and steel, but by people who had only their hands, their observations, their accumulated wisdom, and the deep, unshakable will to survive? This is that story. This is the story of the ancient homes designed to defy storms, time, and collapse, and the extraordinary human minds that imagined them into existence. Let us begin in a place that looks, at first glance, like it should not be able to support human life at all. The Cappadocia region of what is now central Turkey. If you were standing there 10,000 years ago, you would see a landscape so alien, it would seem almost impossible. Vast plains of soft volcanic rock carved by millennia of wind and water into towering cones and columns, called today the fairy chimneys. The ground beneath your feet would be tufa, a soft, porous volcanic stone that you could, with enough patience and the right tools, carve with your own hands. Not cut, not quarry, carve, like clay, like something yielding and cooperative, as though the earth itself was inviting human beings to reach inside it. And that is exactly what they did. The people of Cappadocia, and we must understand that they were not one people but many, across many thousands of years. Hittites and Phrygians, and early Christians and Byzantine communities looked at this strange, carved landscape and saw something that most people throughout history have never seen when they look at a mountain. They did not see an obstacle. They did not see a boundary. They saw a home. They began to carve their dwellings directly into the rock. Not caves in the rough, accidental sense, not dark holes scraped into a hillside out of pure desperation. These were rooms, chambers with carved shelves, with niches for oil lamps, with doorways shaped to human proportion, with ventilation shafts cut at precise angles to allow air to flow while keeping out the rain. They carved churches into the rock with perfectly shaped arches and domed ceilings, decorated with frescoes that had survived for more than 1,000 years. They carved entire cities, not just on the surface, but downward, burrowing deeper and deeper into the earth, level after level, connected by tunnels just wide enough for a person to pass through single file. The underground city of Derinkuyu is perhaps the most breathtaking example. It descends at least 18 levels below the surface. It contains rooms that served as stables and granaries and kitchens and chapels and schools and communal sleeping quarters. It had wells that reached down to the water table. It had massive circular stone doors, each one weighing several tons, that could only be rolled into place or moved from the inside, so that an entire community could seal itself off from the world above and be completely hidden, completely protected, completely self-sufficient for months at a time. At its estimated maximum capacity, Derinkuyu could shelter between 20 and 50,000 people. Why did they build it this way? Why underground? Why so deep, so elaborate, so carefully concealed? Because the surface world was terrifying. Because raiders and armies moved across the plains of Anatolia with devastating regularity. Because the Cappadocian winters are brutal and the summers scorching. Because the tufa rock maintains a constant temperature year-round, cool in summer and warm in winter, making it a naturally perfect insulator. Because the same softness that made it carvable also made it resistant to collapse under its own weight. Tufa does not fracture and shatter under stress the way harder stone does. It compresses, it absorbs. These people had learned something that modern structural engineers would not formally articulate for thousands of years. That flexibility in a building material is sometimes more valuable than rigidity. They had not read any engineering textbook. They had simply watched. They had paid attention. They had learned from the rock itself what the rock was willing to give them, and they had responded with breathtaking ingenuity. Half a world away in what is now the American Southwest, another group of people was solving a completely different set of problems and arriving at solutions so elegant and so precisely adapted to their environment that modern architects still study them with something approaching reverence. The ancestral Pueblones, whom older texts sometimes call the Anasazi, had been living in the Four Corners region, where the states of Utah, Colorado, Arizona, and New Mexico now meet, for thousands of years. They were farmers and traders and astronomers, people of deep intelligence and remarkable cultural sophistication. And they faced a challenge that would have broken a lesser civilization entirely. Their world was one of extremes. Summers brought temperatures above 100 degrees Fahrenheit. Winters plunged below freezing. The rain was unpredictable, sometimes a flood, sometimes a drought that lasted years. The mesa tops where they farmed were exposed to furious winds. And the region sat, as it sits today, on a geologically active landscape where the earth could shake without warning. Their response to all of this was the cliff dwelling. And what a response it was. The most famous of these cliff dwellings is Cliff Palace, in what is now Mesa Verde National Park in Colorado. It was built, constructed, not carved, though the building sits within a natural alcove carved by centuries of water erosion. Between approximately 1190 and 1260 CE, it contains more than 150 rooms and 23 kivas, the circular ceremonial chambers that served as the spiritual heart of Puebloan community life. At its peak, it housed perhaps 120 people. Thousands of years ago, on opposite sides of the world, two distinct cultures embarked on incredible architectural journeys. In the sun-drenched canyons of the American Southwest, the ancestral Pueblones carved cities from cliffs. Meanwhile, on the Mediterranean island of Sardinia, the Nuragic people erected mysterious stone towers that still dominate the landscape today. These were not just buildings. They were statements of ingenuity, community, and a deep connection to the earth. What drove them to build such monumental structures? How did they accomplish these feats with only the tools of their time? And what secrets do these ancient stones still hold? Today, we journey back in time to unravel the architectural genius of the ancestral Pueblones and the Nuragic civilization. Let's begin in North America, in the Four Corners region where Utah, Colorado, Arizona, and New Mexico meet. For over 1,000 years, this was the heartland of the ancestral Puebloan people. Their early homes, known as pit houses, were simple semi-subterranean dwellings. But around the year 750, something changed. They began to build above ground, using intricate masonry to create multi-story villages we now call pueblos. Chaco Canyon, in present-day New Mexico, represents the zenith of this cultural flourishing. Between 850 and 1150, this arid canyon became a major center of Puebloan life. Here, they constructed massive structures known as great houses. The largest, Pueblo Bonito, is an architectural marvel. It contained over 600 rooms, stood 4 stories high in some sections, and was aligned with remarkable astronomical precision. Imagine the planning and labor required. Workers quarried sandstone blocks, shaped them with stone tools, and laid them in precise courses using mud mortar. They transported massive timber beams, some weighing over 200 kilograms, from forests over 75 miles away, all without wheeled vehicles or draft animals. This suggests a highly organized society, capable of mobilizing hundreds of people for a common goal. The walls of Pueblo Bonito show evolving masonry styles, a testament to generations of builders refining their craft. But perhaps the most iconic ancestral Puebloan structures are the cliff dwellings. Think of Mesa Verde in Colorado. Here, entire villages were built into sheltered alcoves high on canyon walls. Cliff Palace, the largest of these, has around 150 rooms and 23 kivas circular, subterranean chambers used for ceremonies. Why move into the cliffs? The reasons are likely complex. These south-facing alcoves offered passive solar heating in the winter and shade in the summer. They were defensible and provided protection from the elements. But accessing them required navigating steep paths and using hand and toe holds carved directly into the rock face. Life was a vertical dance between home, farm, and water source. It was a choice that demanded courage and skill, and it speaks volumes about their adaptability and deep understanding of their environment. By the late 1200s, a combination of prolonged drought and social changes led the ancestral Puebloans to migrate away from these magnificent centers, leaving their silent cities to whisper tales of a remarkable past. Now, let's travel over 6,000 miles east, across the Atlantic, to the island of Sardinia. Here, starting around 1900 BCE, another culture began an architectural tradition that would last for over a millennium, the Nuragic civilization. They are named for their most distinctive creation, the Nurag. Over 7,000 of these conical stone towers still dot the Sardinian landscape. What were they? Fortresses? Temples? Elite residences? The truth is, we're not entirely sure, and they likely served multiple purposes. What we do know is that building them was an extraordinary feat of engineering. The nuragi were constructed using a technique called cyclopean masonry, dry stone walling with massive, irregularly shaped boulders, some weighing several tons. The builders used no mortar. The stability of the structure relied solely on the weight of the stones and the skill of their placement. Inside, the walls curve inward to form a corbelled dome, a beehive-like ceiling that cleverly distributes the immense weight. The most complex nuragi, like Su Nuraxi di Barumani, a UNESCO World Heritage Site, evolved from a single central tower into a sprawling complex with multiple towers, courtyards, and a fortified village surrounding it. This suggests a growing need for defense and a more complex social structure over time. Walking through a nuraj is a powerful experience. The narrow passages, the spiral stone staircases built within the thick walls, and the cool, dark chambers transport you to a different world. You can feel the immense effort and skill that went into its construction. These weren't just shelters. They were symbols of power, identity, and community for the Nuragic people. They were landmarks that anchored clans and villages to their territory. Much like the Puebloans, the Nuragic people had an intimate knowledge of their local materials. They selected the right types of stone basalt, limestone, granite, and exploited their natural cleavage planes to shape them. When we compare these two ancient cultures, separated by an ocean and centuries, fascinating parallels emerge. Both the ancestral Puebloans and the Nuragic people were master masons who used only stone, wood, and earth. Both created large communal structures that served as the social, spiritual, and defensive hearts of their communities. They didn't leave written records, so their architecture is their primary legacy, a physical language that tells their story. The great houses of Chaco Canyon and the Nuradi of Sardinia both demonstrate sophisticated planning, long-term vision, and the ability to organize massive labor projects. Both cultures also demonstrate a profound connection to their environment. The Puebloans didn't just build on the land. They built with it, integrating their homes into the very geology of the canyons. Their architectural choices were driven by the sun, the seasons, and the availability of water. Similarly, the Nuragic towers are a fundamental part of the Sardinian landscape. They are often situated in strategic locations, commanding views over fertile plains, coastal approaches, or mountain passes. Their placement was not random. It was a deliberate act of shaping and controlling their world. What ultimately happened to these master builders? The ancestral Puebloans migrated, their descendants becoming the modern Pueblo peoples of Arizona and New Mexico, who carry on many of their traditions today. The Nuragic civilization slowly faded as foreign powers, the Phoenicians, Carthaginians, and finally the Romans came to dominate Sardinia. Yet, their architectural legacy endures. The cliff dwellings of Mesa Verde and the towers of Sardinia are more than just ruins. They are enduring monuments to human ingenuity and resilience. They challenge our modern notions of what's possible, reminding us that with collaboration, knowledge, and a deep respect for the natural world, ancient peoples could achieve architectural feats that continue to inspire awe and wonder. They are silent testaments, written in stone, to the universal human drive to build, to create a home, and to leave a mark on the world that will last for millennia. Thank you so much for joining us on this journey. If you found this exploration of ancient architecture fascinating, please give this video a like and subscribe to our channel for more deep dives into history's greatest mysteries. We'd love to hear your thoughts in the comments below. Until next time, keep exploring. Let us now travel to the wetlands of southern Iraq, ancient Mesopotamia, the land between the rivers, the cradle of so much of what we call civilization. In the marshes of the Tigris and Euphrates Delta, a people called the Marsh Arabs or Mdan have built homes for thousands of years. Homes that some archaeologists believe descend in unbroken tradition from the very dawn of Sumerian culture more than 5,000 years ago. These homes are made entirely of reeds, not partially of reeds, not framed in wood with reed infill, entirely of reeds, giant Phragmites australis, the common reed, that grows in abundance throughout the marshes, harvested by hand and transformed through a construction technology of extraordinary sophistication into structures that can shelter families, last for decades, and be assembled and disassembled and reassembled in a new location if the water or the land requires it. The great guest houses, the mud heath, are the most architecturally remarkable of these reed structures. They are built by bundling reeds into massive columns, sometimes 2 feet in diameter, and then bending pairs of columns toward each other at the top and lashing them together to form a series of great arches. More reeds are woven horizontally between the arches to form walls and a vaulted ceiling. The entire structure, when completed, forms a barrel-vaulted hall that can be 30 meters long and 6 or 7 meters high inside. It echoes the form of the great brick-vaulted halls of ancient Mesopotamia, and some scholars believe the brick vault may have been inspired by, or may actually have derived from, the reed vault, with early architects attempting to replicate in fired clay what generations of marsh builders had already perfected in living plant material. The engineering logic of the reed mud heath is not immediately obvious, but is, upon examination, brilliant. Reeds are light, far lighter than any stone or even most timbers. But the bundle columns have compressive strength that scales with their diameter. Bundled together, they become enormously strong. The arched form converts the weight of the roof into lateral thrust, which is absorbed by the columns leaning outward into the ground. The whole structure is a compression arch system with no tensile connections, meaning that the reeds do not need to be nailed or bolted or welded together. They are simply tied, and the geometry of the arch holds everything in place by virtue of its shape alone. In the marshes of southern Iraq, the ground is not stable. There is no bedrock to build on, no firm soil that can support the weight of stone walls. The water table is at the surface. The very ground undulates with the seasons and with the floods. A rigid, heavy structure on such ground would sink, crack, and collapse. A light, flexible structure, one that can adjust to ground movement without failing, one that can even be placed on floating reed islands if necessary, is exactly right for this landscape. The Mdan understood this with a depth of knowledge that comes from living in a place for thousands of years, watching what works and what does not, and passing that knowledge forward with perfect fidelity through generation after generation. Why did they build them this way? Because the marsh gave them reeds in abundance and withheld almost everything else. Because flexibility was survival. Because a home that could move with the land was more durable than any home that tried to resist it. High in the Himalayas of Tibet, at altitudes where the air is so thin that exertion feels like swimming through something denser than air, where the wind in winter can tear the breath from a person's mouth, where the temperature can drop to 30 or 40 degrees below zero in a single night. At these extreme altitudes, human beings have been building homes for more than 1,000 years that make the mountain their ally rather than their adversary. The traditional Tibetan rammed earth home, the sangkong, is built from the earth literally underfoot. Workers gather wet earth from the surrounding land, mix it with gravel, and sometimes with a small quantity of straw or animal fiber. Place it in wooden forms and compact it. Ram it with heavy wooden or stone mallets, layer by compacted layer, until the wall rises. The walls are thick, sometimes a meter thick or more, and slightly battered, meaning they lean inward very slightly from base to top, giving the structure a trapezoidal profile that is inherently more stable against lateral forces like wind or seismic activity than a straight vertical wall. Rammed earth construction seems at first consideration fragile. Earth seems so impermanent, so easily eroded, so easily washed away. But properly compacted rammed earth has compressive strength comparable to low-strength concrete. It is essentially man-made sandstone, the same geological process that turns loose sediment into solid rock over millions of years, accelerated by human hands into a single day of construction. The thick walls provide extraordinary thermal mass, absorbing the intense Himalayan sunlight during the short winter days and releasing it slowly through the long, brutal nights, keeping interior temperatures livable when the outside world is lethally cold. The flat roofs of traditional Tibetan homes are not, as they might appear, an aesthetic choice or a cultural convention. They are engineered responses to the specific wind patterns of the high plateau. A pitched roof in the Himalayas would act as a sail, catching the ferocious winds that sweep across the plateau and creating enormous upward lift forces that could tear the structure apart. A flat roof at these altitudes offers no purchase to the wind. The wind simply flows over it. And the thick parapet walls that surround the flat roof, which look from a distance like mere decoration, serve as windbreaks protecting the interior of the roof terrace where families dry food and store, fuel and perform the small daily activities of life from the worst of the gusts. The orientation of Tibetan homes is not random. They face south toward the sun with the largest windows on the southern face, not glass windows in the modern sense, but openings covered with paper or translucent animal membrane that admit light while excluding the worst of the cold. The northern face, turned toward the cold wind that comes down from the high passes, has few or no openings. The building turns its back to the threat and opens its face to the warmth. Why did they build them this way? Because at altitude, every calorie of warmth matters. Because every structural failure is potentially lethal. Because there was no lumber to speak of on the high plateau, but there was earth everywhere. And earth, if you understood it, was enough. On the other side of the world, in the dense rainforests and river floodplains of Southeast Asia, in what is now Malaysia, Indonesia, the Philippines, and across the islands of the Pacific, another architectural tradition addressed an entirely different challenge with an elegance so simple it is almost disarming. The pile-built house. The house on stilts, raised above the ground on wooden posts, sometimes 2 or 3 feet, sometimes 10 or 15 feet. These houses addressed the most fundamental challenge of their environment: the water, the river's flood. The tidal flats are inundated twice a day. The rainforest floor is perpetually damp, perpetually inhabited by insects, reptiles, and pathogens of every description. The ground in these environments is not a friend. It is a hazard. The stilt house lifts the living space out of reach of the flood. It lifts it out of reach of the insects. It creates, beneath the raised floor, a shaded, ventilated space that serves as a stable for animals, a workspace for craftwork, a zone of social activity during the cooler hours of the day. The floor of the raised house is often made of bamboo or split rattan, materials that flex slightly underfoot, that have gaps between the strips to allow air to rise from below through the living space, creating a natural upward ventilation that keeps the interior cool, even in the most humid tropical heat. But the stilt house is more than just an elevated platform. The connection between the posts and the beams above them, the joint, is in many traditional Southeast Asian building traditions a pinned joint rather than a rigid one. This means the post can rotate very slightly within the beam connection, rather than transferring rotational stress directly into the beam. A house built this way can sway. It can rock gently in response to wind or earthquake without the joints failing. It is like the dry stone nuraj and the reed mudheap, a structure that survives by yielding rather than resisting. There is something profound in this principle. The bamboo that bends in the typhoon survives. The oak tree that refuses to bend is the one that falls. These builders had observed this, had absorbed it so deeply that it became encoded in the very way they cut their joints and raised their frames. Why did they build them this way? Because the environment demanded flexibility and elevation. Because the forest gave them bamboo and timber in abundance. Because generations of watching floods and winds had taught them that rigidity was an invitation to destruction. And then there is the igloo. In the Arctic, in the immense howling white darkness of the Arctic winter, where temperatures reach 60 or 70 below zero, and the wind drives ice crystals horizontally with enough force to strip exposed skin raw, the Inuit built shelters from the only material available, snow. The igloo is, by any measure, one of the most structurally ingenious forms ever devised by human beings. It is a dome, more specifically, a corbelled dome, like the Nuragic tholos, in which each successive ring of snow blocks overlaps slightly inward from the ring below, until the dome closes at the top. A key insight, and it is a brilliant one, is that snow blocks, cut from wind-packed snow, are not simply placed on top of each other. They are angled slightly inward as they are laid, so that the entire structure is always in compression, always leaning toward its center of gravity, never in a position to fall outward. The builder cuts the first ring not in a flat circle, but in a gentle helix, so that the dome rises in a continuous spiral rather than in distinct horizontal layers, eliminating the horizontal joints where each ring of blocks meets the next, horizontal joints being the most vulnerable to failure under load. The finished igloo is warm, impossibly, almost magically warm. Outside, the temperature is below zero by dozens of degrees. Inside, warmed only by body heat and a small oil lamp, the temperature rises to near freezing or even slightly above, a difference of 60 or 80 degrees, maintained by a shell of snow that is, in places, only 30 centimeters thick. Snow is warm because it is mostly air. The ice crystals trap air between them, and trapped air is an insulator. The igloo is in engineering terms an insulated dome with a very high surface-to-volume ratio that minimizes heat loss with an entrance tunnel. Designed as a cold trap, the tunnel descends below the level of the floor so that the cold air, which is heavier, pools in the tunnel and never reaches the living space. The sleeping platform inside the igloo is raised above the floor, above the cold trap level, so that the warmest air, rising and pooled under the dome, is precisely where the sleeping people are. Every element of the igloo is a response to the physics of cold and the physics of domes understood not through mathematics, but through the accumulated experience of generations living at the edge of what the human body can endure. Why did they build them this way? Because in the Arctic, there is nothing but snow, and snow, if you understand it, is enough to keep you alive. What do all of these homes, the underground cities of Cappadocia, the cliff palaces of Mesa Verde, the stone towers of Sardinia, the reed halls of the Iraqi marshes, the rammed earth fortresses of Tibet, the stilt houses of Southeast Asia, the snow domes of the Arctic, what do all of these extraordinary, disparate, utterly different structures have in common? They are all conversations. They are all dialogues, sometimes quiet, sometimes urgent, sometimes desperate, between a group of human beings and the specific, demanding, uncompromising reality of the place where they lived. Every design choice, every material selection, every structural form, these are not arbitrary. They are not aesthetic. They are not tradition preserved mindlessly for its own sake. They are answers. Answers to questions that the environment posed with absolute seriousness. How will you stay warm? How will you stay cool? How will you not be crushed? How will you not be blown away? How will you not be drowned? How will you survive when the earth itself moves beneath your feet? And in every case, the answer came from the same source: observation, patience, the willingness to watch. Watch the rock, to watch the snow, to watch the reed, to watch the wind, and to learn what the natural world was willing to teach if only you paid close enough attention. These builders had no structural engineering degrees. They had no finite element analysis software. They had no seismic code requirements or wind load tables. What they had was time. Generations of time. Accumulated knowledge, passed from parent to child, to grandchild, to great-grandchild, each generation adding a small refinement, correcting a small error, deepening the understanding by a small but irreplaceable increment. The result, over hundreds and sometimes thousands of years, was something that looks like genius, because it is genius. Just genius distributed across many lifetimes instead of concentrated in one. There is something else these buildings share, something that is perhaps the most important thing of all. They are honest. They do not pretend to be something they are not. The tufa of Cappadocia does not pretend to be granite. It accepts its softness and offers it as a gift. The snow of the Arctic does not pretend to be stone. It accepts its coldness and uses it as insulation. The reed of the Iraqi marshes does not pretend to be timber. It accepts its lightness and turns it into structural elegance. Every material is used in accordance with its nature, not in defiance of it. Every structure works with the forces acting upon it, rather than trying simply to overpower them. Have you ever stood inside an ancient building, like Cliff Palace in Colorado, or seen photos of the underground city of Derinkuyu in Turkey, and felt a sense of vertigo? Not just a physical dizziness, but an intellectual one. A feeling that the gap between us and those ancient builders isn't as wide as we thought. We live in an age of incredible technological power. We build kilometer-high skyscrapers and design structures that can withstand hurricane-force winds. We can calculate every tiny force on a building with a device that fits in our pocket. In so many ways, we've left these ancient builders in the dust. Or so it seems. And yet, our modern buildings are failing in ways theirs did not. Homes in floodplains get washed away because they're built on the ground, not on stilts. Buildings in earthquake zones collapse because they're too rigid. Our cities become concrete heat islands, and the energy we spend just to heat and cool our homes is a massive environmental problem. But the solutions, things like thermal mass, passive solar design, natural ventilation, they aren't new. They're sitting right there in the archaeological record, waiting for us to rediscover them. And lately, we've started to listen. Architects and engineers are now studying these ancient principles with a new sense of urgency. Rammed earth construction is making a comeback. Passive solar design is now a formal discipline taught in universities. The aerodynamic genius of ancient Sardinian towers is influencing modern wind turbine design. The thermal logic of Tibetan monasteries is being applied to low-energy buildings in cold climates all over the world. The flexible frame construction from Southeast Asia is now part of earthquake-resistant building codes. We aren't reinventing the wheel here. We're just rediscovering it. We're finding that with all our computers and advanced materials, the people who lived thousands of years ago were asking the exact right questions. They used the materials they had: stone, earth, reeds, and they found answers that were structurally brilliant and incredibly enduring. But there's something more to these ancient homes than just clever engineering. These buildings were an expression of a relationship, a deep, intimate connection between a people and their place. The cliff dwellers of Mesa Verde didn't just build asterisk in asterisk the cliff. They became part of the cliff, and the cliff became part of them. The people of Cappadocia didn't just live underground. The underground became their entire world, shaped by their hands, with the line between what was natural and what was human completely blurred. This is what we've lost. And it might be the most important lesson these ancient builders have for us. It's not about a specific building technique, like a corbelled vault or a flexible joint. We can learn those from books and imitate them with modern materials. What's much harder to learn is the quality of attention they paid to their world, the depth of their observation, the sheer patience of their learning process. They didn't demand that their environment change to suit them. Instead, they asked what it was willing to give, and they built within those limits. And what they built has outlasted them by millennia. It has survived the storms, the earthquakes, the floods, and the slow decay of time itself. It survived because it wasn't built in opposition to nature, but in conversation with it. A conversation that spanned centuries, carried out in stone and earth and snow, by people who understood that they didn't own the world they lived in. They were only borrowing it. So they built homes that the world could accept. Something a mountain wouldn't reject. Something a storm would pass over instead of tearing apart. Something that, even after thousands of years, is still standing. Think about your own home tonight. Its walls were likely built in days, not generations, from materials sourced from all over the world, assembled by people who will never know the ground beneath your floor. And this brings us to the most haunting question these ancient builders leave us with. It's not how they built what they did, or even why. It asks this: Will what we have built outlast us the way their buildings have outlasted them? And if the answer is no, what does that say about what we've forgotten? What have we stopped listening to? What does that say about us? The stones of Cappadocia are still there. Cliff Palace still clings to its ledge. The Nuraghi towers still stand under the Sardinian sun. They are waiting, with the patience of things built to last forever, for us to come back and remember what they know. Thanks for watching. If this made you think, consider subscribing for more stories about the wisdom hidden in our past. See you next time.